Hello teachers, welcome back to our section or our chapter on transformations, and in this section we're going to talk about reflections and glide refractions. When you finish this section, you should be able to understand and discuss a reflection in a line and its construction, coordinate representation of reflections in the x-axis, the y-axis, and the line y equals x, an application of reflections, glide reflections and their constructions, and then congruency via isometries. Reflections. Another isometry is a reflection or a flip. One example of a reflection often encountered in our daily lives is a mirror image. A reflection in a line L is a transformation of a plane that pairs each point P of the plane with a point P primed in such a way that L is the perpendicular bisector of P primed as long as P is not on L. If P is on L, then P is P primed. It's the same point. So you're going to see this. Don't worry if that definition was just a little bit confusing taking it in. You're going to see reflections coming up in examples. We can obtain reflections in a line in various ways. Folding the paper along the reflecting line and drawing the image gives the mirror image or image of the half tree. So notice here, if you just fold your paper along the reflected line like it's depicted in A, okay, then it reflects through, and you see the pre-image is the original image on the left, and then the reflected image there on the right. It says another way to simulate a reflection in a line involves using a mirror or a mirror. This is not something that I'm familiar with and really doesn't show up in the remainder of my PowerPoint, but it appears to be like a mirror that you can put along your reflecting line and you see your image reflects through. Constructing a reflection by using tracing paper. So this is a good way to build a reflection, and what you would do is you would trace the image. So notice the brown paper is like your tracing paper, and you would trace the image on your tracing paper along with the reflecting line. Okay, then you need to flip the tracing paper over to perform the reflection. So the drawing is actually going to be on the bottom side of the tracing paper, but you'll be able to still see it through and see this is exactly what we're talking about, reflecting an image. Notice none of the points of the triangle here lie along the line, so none of the points stay the same, but in the tree image, you see there are points both at the top and at the bottom that lie along the line, and any point that lies along the reflecting line stays on the reflecting line. Every other point travels through. Okay. Here's our first official example of reflecting an image. So notice we have the triangle ABC, and we're going to reflect this through the line M. I'm going to try to do it by hand first to kind of talk you through this and then show you the computer generated version of this reflection. So notice the point C, when it reflects through, it's also going to be C primed. I still have C primed label over here. So again, when C reflects through, because it's on the line of reflection, then it's going to stay. Okay, but point A, now check this out. The lines I'm going to draw here are going to be green, and these are lines, okay, that these are perpendicular lines to your reflection line. And so this same distance, okay, so the same distance from here, and notice this is perpendicular, will reflect right through there. So this is going to be the point A primed. Okay, let's see if we can do the same thing with B to create B primed. Again, I need a perpendicular line to my reflecting line. So from B, a perpendicular line is going to be right there, and I keep going that same distance, and this is going to give me B primed over here. And then I connect the dots. Okay, so we connect A primed to B primed to C primed, and C primed back to A, and there is my reflection through the line M. Okay, now when you see the generated version, there it is. Notice that matches up, but again, what's very important here is drawing a perpendicular line to your reflection line from your point to your reflected image over here. So again, that line is perpendicular. This line is on the reflection line, so we can't do that there, but this line is also perpendicular to the reflecting line. That's really the key to doing this. For some reflecting lines, like the x-axis and the y-axis and the line y equals x, it is quite easy to find the coordinates of the image given the coordinates of the point. So let me just show you a quick example, and then I've got more. This is not the only examples we're going to do here, but just a super quick xy axis. Okay, and let's just say we have the point 1, 2 right here. Now, first, let's reflect through the x-axis. So our reflection line is right there, right? So picture reflecting through. Now, if we use the trick that we used before by drawing a line perpendicular, so there we go, to the reflection line, which is green, the x-axis, and then we're going to go that same distance to the other side, and there is your point. What is that point? Well, the x value stayed the same, the y value changed. So if you're reflecting through the x-axis, notice what happens again. The x value stays the same, but the y value is opposite. Now let's try that again, and let's take a look at the y-axis situation. So again, let's stick to the same point, the point 1, 2. Okay, now my reflecting line, I'm still going to do, let's do it in a different color. Let's do the highlighter purple, is y equals x. Okay, so it's this line right here. No, I'm sorry. It's the y-axis. We're not to y equals x yet. Hang tight. So the y-axis is where I'm reflecting. Okay, now as you can imagine, and like we talked about just a few minutes ago, I need to draw a line perpendicular to my purple reflection line here. So if I draw perpendicular, it would be right here. And then I go on the other side that same distance to get my image. Okay, well, what changes? Well, the y value stays the same. That's still up there at 2. You know what changed? The x value turned negative. So if you're reflecting through the y-axis, what happens is your x changes to the opposite sign and your y value stays the same. Okay, now last case scenario that we've got listed here. So we did this one in purple, and let's do this one in, how about pink? Okay, so y equals x. That's what we want to take a look at. So I'm going to draw a super basic xy axis once again. And I'm going to show you the point 1, 2. Let's be consistent. So I'm going to look at the point 1, 2. Now the line y equals x is this line right here. It goes through a 45-degree angle through the positive x-axis. Okay, right there is 45-degree angle. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 4, you see the point that I'm trying to get at there. A lot of people think about that as the slope of 1. But this is the line, y equals x. And I'm trying to reflect through that line. So that's why I'm going to highlight that pink right there. Okay, now again, if we're consistent about how we draw this, we're supposed to go to the axis of reflection, or the reflecting line, so perpendicular to it like that, and then I'm going to go that same distance on the other side. Now here it is not so clear exactly what's happening, but it would be this point right here, and that is the point, as you may have thought, 2, 1. So remember, this was originally 1, 2. When you reflect through the line y equals x, it reverses. Your x turns into y, and your y turns into your x value. So hopefully that kind of gave you a quick rundown of what what would happen if you reflect through those lines. And here's another example so you can see this more clearly, but we're just focused on the line y equals x this time. Okay, and notice the points we're looking at. Here's a point right here, 1, 4. Remember, if you reflect through the line, that's going to switch the xy, and you're going to get the point 4, 1. Okay, and it says it right there. The image of A1, 4 reflects through, and it's 4, 1. Well, what about the image -3, 0? When we reflect that through, it's going to end up being 0, -3. And again, remember, the important thing is you come to your reflection line perpendicular, and you keep going through to get your other image point. Same thing here. Perpendicular, same distance on the other side, and then there is your image point. Okay, so the image of -3, 0 is 0, -3, but that brings me to the question, what about the x-axis or the y-axis? So first, let's reflect 1, 4 through the x-axis. So if we reflect the image 1, 4, that's going to turn into, remember we talked about that, the x-axis is right here. Let's draw it on there so you can clearly see this is the x-axis. If I reflect 1, 4, it's going to go on the other side, and it's going to be 1, -4. Or if I reflect -3, 0 through the x-axis again, -3, 0, look, it's already on the line, so it stays -3, 0. In other words, how do you change 0 to a -0? It stays the same. Now what about y-axis? I'm going to go to the top of the screen to write this down. So if we're looking at y-axis this time, I want to take a look at what happens to 1, 4, and I will also want to take a look at what happens to -3, 0. Okay, now what I do want to do is get rid of my highlighted line, and let's do a brand new one, and the y-axis is this guy right here. So picture reflecting 1, 4 through the y-axis. Okay, and that's going to be clear on the other side right here. That's going to be -1, 4. We talked about that rule before, right? Or if I move -3, 0, that was my original, yes, -3, 0, and I put that through the y-axis. Remember, you go perpendicular, and then that many on the other side, that's going to be +3, 0, isn't it? And again, what are you changing? When you reflect through the y-axis, you're doing the opposite of x, and when you reflect through the x-axis, you're doing the opposite of y. All right, folks, I have a homework problem for you here, and you know, typically when I give you homework examples in the lecture, it's because they are not just self-evident and something I feel like that's easy to figure out on your own, although I know all of these you could, but I'm trying to save you a little bit of time. So given triangle ABC, and its reflection image of triangle A prime, B prime, C prime. So you see it there. It says find the line of reflection. And then they want us to graph it. And from what I can tell, this is the very first problem within this course where we actually have to use the graphing tool that shows up in our course. So it's great to use, it's fun, but I want to talk you through this process. Okay, so what we're trying to do is find the line of reflection. We can see it's reflected. If we just had to guess, and don't guess, this is not what we're going to do. I just want you to visualize it somewhere in here, right? So A turned into A prime, C turned into C prime, and B turned into B prime. Now here's the plan to get this done, okay? First of all, I don't even know what these points are. If this was a regular XY axis where I could see the X axis and the Y axis, I could label these points. And that's the first issue I had when I was doing the homework myself. I'm like, what in the world? How do I even know what those points are? Do I need to create my own scale to get this done? Well, turns out if you click right here to enlarge the graph, you can use the graph to help you out a little bit. So next slide, let me show you here. I clicked it, okay? And then the next thing I did is I clicked the straight line tool because I know I'm going to be graphing a straight line. It's a line of reflection. And I highlighted it over there for you, but I'm going to go green with it. And it's still not showing up very much. But you see what I did? I clicked that straight line that's at the very top of your toolbox over here. Now, when I did that, you can move the point around. See, it's like in crosshairs right here. And I slid it over to A to find out what A was. And went, oh, so A is at -3, 5. Now, again, it doesn't give you that in the problem. It doesn't give you that when you look at any of the information. I had to click back on, again, remind you, click on that, click to enlarge graph. Then I had to select that I wanted to use the straight line. And then I can move around these crosshairs on my point. So that's what I did. I found out where A was. I found out where A primed is. So if I could pick this up for you and slide it right over here, we could read A primed right here. I found out what C was, and I found out what C primed is. Okay, so my next slide, I went ahead and gave you that information. I found out what they are. Okay, now here's what we've got to do to pull this job off. We've got to calculate the midpoint of each point and its reflected point. So remember, I gave you kind of the reflected line's going to look about like that. Here's the idea of what we're doing. Okay, remember that the reflected line, well, the reflected line is here, but what I'm trying to say is if you connect A and A primed, the reflected line is a perpendicular bisector of that. If I connect C and C primed, then the reflected line has to meet perpendicular, and it divides this in half. So the key is to find the midpoint of your image and your original pre-image and your reflected point, which is your image. So I'm going to find the midpoint of negative 3, 5 and 5, 3. Okay, so here we go, negative 3, 5 and 5, 3. Now your midpoint formula, it's probably been a long time since you've seen this. You add your x's together and you divide by 2. In other words, it's just the average of your x values is your x coordinate, and then the average of your y values is the y coordinate. It's very easy, okay? So I'm supposed to add my two x's together. That's going to be negative 3 plus 5 and divide that by 2. And then I'm going to add my y's together, 5 plus 3 and divide that by 2. Okay? Now that's going to give me my point. Negative 3 plus 5 is 2 over 2, which we know is 1. I'll simplify that in a minute. 5 plus 3 is 8. Divided by 2 is 4. So my midpoint is 1, 4. Okay, so 1, 4 for the first one. So if I were to graph that, I can't, again, nothing is labeled. So it's not that easy to find 1, 4. Now I do know that, excuse me, A is negative 3, 5. So if I went over to 1, 4, I'm just going to guess it's somewhere right in there, okay? I'm going to show you a better image of this in just a minute. But now in green, I would like to do the midpoint again, but this time for my C and C primed, which again, I had to go on the graph to find out what those values are by using my graphing tool. So I'm going to add my x's together and divide by 2. So that's going to be negative 9 plus 7, always watch your signs, divided by 2, and then 2 plus a negative 6, divided by 2. Okay, negative 9 plus 7 is negative 2, divided by 2 is negative 1, and then 2 plus negative 6 is negative 4, divided by 2 is negative 2. So I've got two different midpoint values. I've got 1, 4, and this one should be about negative 1, negative 2. So the next thing I do, again with my line tool, it's still clicked. It doesn't appear to be clicked here. It really is. This is my line tool. It's been selected. Okay, and I plotted that point. Remember that first one was 1, 4. So this is the point 1, 4. And when you click on 1, 4, make sure it's 1, 4, then a line will pop up for you and you can move it around until you click your second point, which is right here at negative 1, 2. Okay, and then you can just visually check it. Like if I were to draw, again, a line from A to A primed, is this line right here perpendicular? It appears to be. If I were to draw C to C primed, again, is that line perpendicular? And not only that, it has to bisect. So this distance over here has to be the same distance as this over here, and this is exactly why I found the midpoint. We could have done the same thing for B and B prime. Notice I only did it for 2 points. You know why? Because you only need to do 2 points to graph a straight line. And so, but if I visually check that, it appears to be perpendicular, and it is the same distance from B to the line as it is from the line to B primed over here. Okay, so that's the idea to get that done. I don't think it was terribly intuitive by just reading the problem, and this is exactly why I picked the homeworks to do for you in the videos. And I found another one. So homework example 2, this is not your number 2 in the homework, is just an example and I'm calling it 2. I'm not even giving you the entire problem. It's quite a thinker, and that's the goal. That's what you need to be doing in the homework. But this one was just a little bit challenging, I thought, and it would be good to talk about together as a class. So here we go. So with an appropriate font, the image of 1881 is 1881 after reflection in either the horizontal or vertical axis, as shown in the figure. So notice they have the blue line, that's your vertical reflection. Notice if you reflect through the vertical line, you know, it just reflects right back on top of itself. Same thing holds if you reflect through the horizontal line. It's really a very interesting number. But then they go in and ask something big. It says, what natural numbers less than 2,000 have this property? So really it's a question that you really probably need to pause the video and sit and just ponder this idea, but I didn't want to leave you hanging just typing in number after number after number and going, is this too many, is this not enough, and continuing to get it wrong. So this is a great discussion together. The first thing I had to do to think through this problem is I needed to list all the numbers that have that property. You know, 1 and 8 you see reflects again horizontally and vertically. Okay, are there any other digits that do that? So if we list all the digits between, you know, 0 and 9, so 0, 1, 2, 3, 4, 5, 6, 7, I just want to visually look at them, 8, 9, right? We don't need to list 10 because 10 is made up with a 1 and a 0. Okay, now let's highlight the ones that will behave in this way. So if I reflect 0, okay, vertically, upside down, well, you got to draw a line through it. So let's do exactly what they did over here with their blue lines. Okay, so if I draw this way or this way, notice that would work, right? It's going to reflect through the horizontal axis. It's going to reflect through the vertical axis. So 0 is a winner. 0 needs to be on our list as a keeper. We already know 1's on the list. Again, if I drew, it's going to turn into a mess. You won't see the number 1 anymore, but if I drew my lines on top of that, it's going to reflect over and left to right. So 1 is good, and even if it wasn't in the center, you know, it's going to reflect through. But 2, y'all, 2's not going to work out, right? There's no way. That doesn't flip through and reflect. Neither is 3. Now, 3 is interesting. It would reflect horizontally, right? If I drew the line right here, it's going to reflect through and look the same. But what about vertically? You know, it's not. Its shape's going to be the other way. You know, like when little ones, when they first start drawing 3s, they're backwards. That's what would happen. 4 is out for multiple reasons. It's not going to reflect horizontally or vertically, and neither is 5. And I'm putting X's on them, but I need to be doing the slashes, right? 6 doesn't have any symmetry that we could use. 7 doesn't either. We already know 8's on the list. What do you think about 9? No, 9's off the list. Now, y'all, here's where the fun part comes in. We have 3 digits that this will work out with, but we've got to imagine reflecting them through and all the way up to 2,000. So we are building numbers between 0 and I say between 0. Notice it says natural numbers. So 0 by itself is not going to be on the list, but we can only use these 3 digits. And you got to be careful. It's not every single combination of these 3 digits because it depends on their arrangement about how they reflect through. So everybody agrees natural numbers start with 1, and 1 is on our list. It's going to reflect vertically and horizontally. The next number on the list is 8. Again, you can draw your cross through there, and it's going to reflect through both. What do you think is next that might work? My first thought was 18. But you know what? 11 is on the list. Okay, so if I draw, again, I need something light here. Hold on. Let's do yellow. So if I draw through here and here, you see that would reflect through. And then back to 18, but you know what? 18 doesn't work. When I reflect through here and here, that reflects over, then it would be 81. So 18 is not one of our guys. 18 is off the list. Okay, so again, it's a lot to think about. You've got to build up to this. So then you start thinking, okay, I need 10's not going to work, right? The reason 18 doesn't work. What about 80? No. So you need some symmetry in your numbers. The next one on the list is actually 88. Again, if we draw our crosshairs through like that, you could see you could reflect horizontally, you could reflect vertically. What do you think about next? And again, I do think it's worth pausing it because we don't want to turn this into a one-sided me only talking 25-minute conversation, but that's what this really is. It takes time to think through this. So maybe pause it and see if you can think through your list, but I'm not going to let you leave until you actually have the list in front of you because I don't want you to get frustrated with this homework question. Did you go back? Did you do it yourself? Oh, seriously, pause it and do some of these. Okay, so you're back. You did it. So the next number on the list is actually, you might have missed this one, is 101. Again, if I draw my crosshairs through, I didn't do that very symmetrically, but you could see you could reflect this way. The 1 would land on top of the 1. The 0 splits itself up. Same thing across the horizontal axis. So right now we have 1, 8, 11, 88, 101. What about the next one on the list? If you put 111, fabulous. Draw your crosshairs through that. I promise it works. And then you start thinking, you need 1s and 8s, right? So how about symmetry here? How about 181? Wouldn't that work great? So you draw your line through this way, you draw your line through that way. And my suggestion is play with these 1s, 8s, and 0s in every possible way that you could combine them together. Going in numerical order would help a lot. And then draw your crosshairs through and just see if it works out. Okay. The next one on the list, believe it or not, jumps all the way. That's all the ones that could start with 1 that would work. And then we've considered everything that would start with 0 because we're not even including 0. These are counting numbers, and we started with 1s. Now let's start with 8s. Okay, so then we have 808, right? Draw your crosshairs through there. It works great. Can you think of maybe the next number? You know what I left out? No, I didn't. I got it in there. I thought I left out 101, but it is there. Yay. After 808 would be 818. You see that? That would work perfect. So the line would be actually right on top of the 1 and then flip through there, reflected through. You've got it. And then a really cool one would be 888, right? And then draw a line through. Perfect. Okay. How about 1001? That would be the next one in line. Again, really great symmetry with 1001. It divides the number with 2 on each side and then reflects through. And then next would be 1111. If 111 worked, it seems reasonable that 1111 would work. Again, divide, divide, yay, got it. And then we're only missing 1. And you know what that is. That's 1881. Okay, so that's all the natural numbers. So 1, 8, 11, 88, 101, 111, 181, 808, 818, 888, 1001, and 1111. You could probably try to think more. Thank goodness they cut it off at 2000. They could have made that a little bit lower, but I guess they wanted to make sure you included 1881. Fun question, but if you're in a hurry, it will just give you nightmarish feelings. So I'm glad we talked about it together. And here's a third homework example for you. They kind of clustered all right here in the middle of the lecture. We're going to do this homework example together, and then I'm going to shut it down because I've gotten to my 30-minute mark almost, and then we'll come back for part 2 to finish up this section on reflection. So let's find the equation of the images of the following lines when the reflection line is the x-axis. So again, important things here. Our reflection line is the x-axis, and it's 2 different questions. So we're going to focus on y equals negative 2x plus 4 to start with. Okay. Now, one thing you could do is you could just graph the line negative 2x plus 4 and imagine or draw the reflection line and see if you can pull that off. And I highly suggest that. But if you want a method for handling that, here we go. So find points on the given line, then apply the reflection to that line. And we've already talked about how you reflect points through. Then write an equation for the new line using the reflected points. Okay, so here's what I'm asking. I need some points on that line. So we can plug in whatever you want, but I am focused again on the line y. Come on, pen. Y is equal to negative 2x plus 4. So you know the rules. You can plug in anything you want for x, and it's going to spit out the y coordinate when you plug it in the equation. So what I'm going to do is, hey, let's just plug in x equals 0 and see what we get. So that will give me y is equal to negative 2 times, remember I'm plugging in, there's my 0, then I'm plugging in right there, plus 4. When I simplify that, that's going to give me negative 2 times 0, 0 plus 4 is 4. So I have the point 0, 4 that's included on the line negative 2x plus 4. Okay, let's find another point. Okay, so let's plug in, I'm going to go to the top of this page over here. How about x is equal to, I don't know, negative 2? Or 2. Let's do 2. It works out nicely, but y'all, 1 would work fine. 3 would work fine. You might want to use anything. If you get fractions as a result, you might want to avoid those just for ease of calculations. And if you had to graph this, that's, you know, fractions can be a problem when you do a computer-generated graph. I don't believe that you have to graph this one, though. Okay, so x equals 2. Let's plug it in. So that would be y is equal to negative 2. Again, I'm removing the x value, and I'm plugging in 2 in that position. And then the equation goes on to say plus 4. Well, negative 2 times 2 is negative 4 plus 4. And that gives me y is equal to 0. So the point, or the coordinate, is going to be 2, 0. So we have 2 points. We have the point 0, 4 and the point 2, 0 that lie on the line y equals negative 2x plus 4. What do we do with those? Now we reflect through our line. We're reflecting through the x-axis, remember? So if I reflect the point 0, 4 through the x-axis, remember, okay, so let's draw a picture. Okay, so 0, 4 is right here. That's 0, 4. If I reflect that through the x-axis right here, it's going to come down here and it's going to be 0, negative 4, right? Remember the rule, when you reflect through the x-axis, the y-axis goes opposite. So same thing is going to happen here. When I reflect through the x-axis, the y-axis goes opposite. So 2 opposite of 0 is still 0, right? Is that okay? Absolutely. Okay, so we now have the points 0, negative 4, and 2, 0. Now the next thing I'm supposed to do is write an equation. Y'all, I select the pen. It's so frustrating. I apologize. Write an equation, still not writing, of the new line using the reflected points. Okay, do y'all remember how to write the equation of a line? You might need a bit of review for that, so I'm going to give you the full review. Okay, so you see I wrote top half of the screen 0, negative 4, and 2, 0. Those are our reflected points, okay? So to write the equation of a line, you need the formula. There's a couple of ways to do it, but one of them is y minus y1 is equal to m times x minus x1, okay? Another way is to use y equals mx plus b, but this is, to me, easier to deal with. Now, what you need to plug into this formula is you need an m, which is a slope, a y1, and an x1. And we have a y1 and an x1. It's your choice if you'd like to use 0, negative 4, or 2, 0. The reason we have 2 points is to find the slope. You probably remember the formula for slope. M is equal to y2 minus y1 over x2 minus x1. We have to use that first. So y2 over here is 0 minus y1 is negative 4, and that's divided by x2, which is 0. It's 2. Let's back up. Okay, is 2 over x1, which is 0. Make sure you're comfortable with how I plugged in there. So again, 0 minus negative 4 because y's go on top, and then 2 minus 0 because x's are subtracted in the denominator. It gives me positive 4 over 2, or my slope is 2. So I'm going to use that for my m value. And then here I go, y minus y1. I'm just going to use, let's use this point, the second point. It'll be easier. Y minus 0 equals, my slope is 2 times x minus 2. Okay, gives me y is equal to 2 times x minus 2. Distribute the 2, y is equal to 2x minus 4. That is the equation of the reflecting line. Okay, so find the equation of the image. So this is the image equation, and this is the original equation. Now what I have graphed for you here is y equals negative 2x plus 4, the original. Let's quickly graph our reflection. We got negative is 2x minus 4, so that means my y-intercept is at negative 4. And I'm supposed to rise 2 and run 1. And that's going to give me, and then rise 2 and run 1. And I shouldn't be graphing with a highlighter. But that's it. Okay, that's our reflecting line, again, through the x-axis. So I said that wrong. That is our image line. Our reflecting line, remember, is the x-axis. Boom, right there. And then our purple line was the answer. So that was y equals 2x minus 4. Okay? All right. Almost done, y'all. Almost done. I know I'm way over my time. Let's look at y equals 1. Okay? I've got it graphed for you here, right here. Now, that one's a little bit easier to think about without all the stress. We could do exactly what we did a minute ago. There are some things to think about, but look, if we reflect it through the line, remember, here's our reflection line. If we reflect that horizontal line through x equals 0, the x-axis, which is y equals 0, it's just going to be our green dude right here, which is just going to be y equals negative 1. Okay, that one's a little easier to see without all the writing the equation of a line stuff. So I'm going to shut the video down because I'm like way over time. Please come back for part 2 where we will wrap up our discussion about reflections and glide reflections. I hope you have a good day.